tolerance reagent. So we did a sort of mirror reaction. Basically, it's just a test to see if there's an aldehyde in whatever it is you want to see. Like, oh, this chemical does have an aldehyde, put the tolerance reagent in, and it'll tell you, because most sugars or aldehydes can be reduced or oxidized to form a carboxylic acid, or the anion form of the carboxylic acid. And you form a carboxylic acid under acidic conditions, so if you have acid in there, and if you have it in basic conditions, you form this anion. And so the tolerance reagent would just act as a way to oxidize the aldehyde group, and whatever it is. In our case, we use sugar, but it can be any aldehyde. So it just has to see if there actually is that group there. If it isn't, the reaction won't take place. But if there is, this reaction will take place, and silver will get reduced to solid silver. The first step in the mirror reaction is to make the tolerance reagent. What we did was we added a solution of 1 molar silver nitrate to a solution of 0.3 molar silver nitrate. And this gave us the tolerance reagent and some other stuff that really doesn't matter. And this was added to another flask that contained dextrose. And then right after we add the tolerance reagent, we immediately add the basic NaOH, sodium hydroxide, 0.8 molar, I believe. And this quickly swirl around to give the reaction time to react, and mostly to really cover the whole flask in silver, because this whole thing, what happens is the dextrose, the aldehyde in the dextrose gets oxidized to form the carboxylic acid, or the anion of the carboxylic acid, which means that something has to get reduced, which will end up being the silver atom. This gets reduced to its elemental form, or just plain silver solid, and that gets plated around whatever it is you're doing. In this case was a flask. In the video you see it get the solution turn brown, and then swirl it, and then covers the whole flask in silver because it gets reduced.
So I'm here to explain the role of dextrose and our tolerance reagent. So our dextrose sugar is a reducing sugar, which means that it will help the silver be reduced. However, itself will become oxidized, as we can tell, because an aldehyde, which is dextrose, will oxidize into a carboxylic acid, like such. However, in terms of silver, silver will be reduced. So initially, if we look at the oxidation state, we can see that OH is usually a -1 charge, and then NH3 is usually 0, which means that in order for this entire tolerance reagent to be to have an oxidation state of 0, it means that the Ag, the silver, has to be a positive or +1. And based on oil rig, we can tell that if Ag silver is +1 and we want to reduce it, the electron is added so that it causes the oxidation state of Ag solid, as shown in our equation here, to be 0. So because the oxidation state has gone down, we can conclude that this is indeed reduction. So in terms of safety, the first thing to notice is that we are dealing with a strong base, and a strong base is corrosive and it is very toxic. Another thing to point out in terms of safety is when we are making our tolerance reagent, we are using silver nitrate and ammonium nitrate. Specifically with the ammonium nitrate, that is considered toxic by ingestion. And then in terms of the silver nitrate, it is an irritant and it will stain your clothes. It will stain your skin. So make sure you're wearing protective gear for that. And then finally, when we are actually reducing the dextrose sugar, it is important to make sure that we are running this with copious amounts of water, and at the same time to make sure that it doesn't end up dry, because if it does, it will eventually become a solid, and it could have the potential of making a small explosion.
So let's get into the history of mirrors. A mirror is a reflective surface that does not allow the passage of light and instead bounces it off, thus producing an image. The most familiar type of mirror is the plane mirror, which has a flat surface. Mirrors have been known to men since ancient times. The first mirrors used by humans were most likely pools of dark, still water or a water container that caused a reflection of the viewer. The first known manufactured mirrors were located in Anatolia, approximately in 6000 BC. They used a variety of crystals and stones to make these early forms of mirrors. Examples include obsidian, which is a black volcanic glass, mica, and polished iron pyrite. However, with the development of copper and copper alloys, including bronze, molded metals became the substances of choice for mirror manufacture. Mirrors of polished copper were crafted in Mesopotamia from 4000 BC and in ancient Egypt from around 3000 BC, just to name a few. There were limits to using copper and such due to the oxidation of the metal by the atmosphere and abrasion of the metal surface. These simple mirrors did not last very long, so there was a need for further development. The invention of the silver glass mirror is credited to German chemist Justus von Liebig in 1835. He invented the silvering process used in this demonstration. This process involves the deposition of a thin layer of metallic silver onto glass through the chemical reduction of silver nitrate. The silvering process changed the manufacturing and affordability of mirrors. Today we encounter mirrors on a day-to-day basis and are prevalent in almost all aspects of our lives. Just some examples of the importance and relevance of mirrors include mirrors for personal grooming, mirrors for driving, including rear view mirrors and convex mirrors to minimize blind spots, and dental mirrors. Additionally, mirrors are integral parts of a solar power plant, and as renewable energy increases, the need for them will also increase. Microscopic mirrors are also a very important element for high-definition televisions and video projectors. This is known as a DLP chip, whose surface is an array of millions of microscopic mirrors. These are just a few examples as to why mirrors are so relevant in our lives and the importance of them. I hope this video was informative about the silver nitrate mirror reaction and provided a context of the history and relevance of mirrors. Thank you for watching.